Hello and welcome to this recording on measures of association and effect. In this recording, we will be reviewing quickly relative risk and odds ratio. I'll mention them, but our main focus is going to be on attributable risk and attributable risk percent, and then population attributable risk and population attributable risk percent. That's a mouthful. So I'll just call them AR and AR percent and PAR and PAR percent. So let's start out by reviewing one of the examples that you had in your textbook from page 349. And it was a sample problem for relative risk. And what I'd like to do is to use that same exact problem and go ahead and review the relative risk, but then also cover these new concepts with the same data so that you can see how to use the same exact numbers and calculate something different that gives you a different view of that particular question. So really quickly, we had an exposure, which was abuse, and we had an outcome, which was suicide. And this was, just as a reminder, from a population of chemically dependent adolescents. So I'm going to go ahead and write that up here. The population was chemically dependent adolescents. So that's who we are trying to expand to. We're trying to be able to have some meaningful information. We obviously only have a sample. There are lots of chemically dependent adolescents in the U.S. and that we could extrapolate these findings to. So in terms of the actual numbers, we had a total of 23 who were, let's actually start with the total. We had 221 individuals who were in this study. So we'll say total. And of those, 198 did not have a history of abuse as it was defined for that particular study, and then 23 out of the 221 did have a history of abuse as it was defined. And then what happened is they followed them forward in time and they found out if the outcome occurred, which was suicide. And unfortunately, in 14 of the those exposed to abuse did have suicide, and 49 of those who were not abused had a suicide. And if we're to complete this, that means there were a total of 63 suicides. Now, these numbers are not completely irrelevant. Remember, we need to have those numbers in order to calculate the odds ratio. Odds ratio is this little A over B divided by C over D. And I hate those terms, so I'm erasing them. Because it's problematic for some people. If the table is set up wrong, if the outcome and exposure columns and rows are traded, you will not calculate the right outcome and exposure, or sorry, the right odds ratio. And for everything that we're doing today in terms of the attributable risk, population attributable risk, and so on, we don't really need those. They're obvious to calculate, so I think it sometimes confuses to have all of those cells filled in. If you want to fill them in and that helps you, then go ahead and do that. If we were to calculate the risk, then for each of these groups, exposed and not exposed, the risk for, I'll just put 14 over 23 is equal to the risk, and I'm going to use a little lowercase e, risk e. Let me make that clearer. Risk sub e is equal to, it ends up being 60.9% or 0.609. Either one of those is fine. Or you could say, instead of percent, you could say per 100. That would also be a good measure. And then similarly, the risk for the unexposed is 49 per 198. So I'll call that risk of unexposed. That's a U, is equal to 24.7 per 100. Now those per hundreds could be, depending on the actual numbers that you're getting for a study, could be per thousand, per 100,000, expressed in different ways, but we just need to keep it consistent between the different things. Now our relative risk then, remember, is, and I'll just put it over here as a reminder, is equal to 60.9 divided by 24.7 is equal to 2.46. So that's our relative risk. In terms of the total then, I'm going to also use these numbers and do something with them. I'm going to say the total risk for this particular group, remember here we have our population of chemically dependent adolescents, is 63 divided by 221, which I'll call risk total, that's a T, is equal to, and you can calculate this out, 28.5 per 100. So those are some of the numbers that we will be using for the next little bit. So I already did a quick reminder of relative risk, and what I'd like to do is to draw that relative risk for you really quickly here on a graph so that we can kind of be on the same page with this. So in terms of the risk, and I'll just put no and yes here, the risk in the yes exposed then is going to be 0.609, or slightly above 60%. So we'll draw ourselves a little bar here. That's probably a little too high above, but that's our risk among the exposed, those yes exposed to abuse. And then the risk in the unexposed was 24. I'm just going to say that's kind of like right about in here. So we'll draw that like so, and hopefully my inaccuracy doesn't make that hard for you. So 0.247 or 24.7 per 100. Those are the same thing. Now we can do something interesting over here. We can say that if we were to try to do something here with relative risk, this 2.46 is an interesting number. If we were to follow this 0.247 across to here, we would call this a relative risk of 1.0. And then proportionately, this 0.609 is at the 2.46 mark. And so this is, if this distance from here to here is a 1, then this would be another 1.46 higher. And so we've basically just made that proportionately above the 0 mark. And so these two numbers, which is kind of interesting, 0.609 and 2.46, really are proportionately higher than the two numbers that we've seen before. So that's a quick review of relative risk. Our first number that we are going to calculate is called attributable risk. So here's our risk. We're going to calculate attributable risk. And the attributable risk simply is equal to the risk in the exposed minus the risk in the unexposed divided, or actually not divided, sorry, minus the risk in the unexposed. So this would be, for our specific example, this would be 60.9 minus 24.7. And both of these are, in your own mind, you can remember these are per 100. This is per 100. So that is equal to 36.2 per 100. In other words, let me go ahead and draw where that is. If we were to take this 60.9 and subtract out 24.7, it's this distance right here. It's the amount that it's above what we would expect in that group if there were no association between the exposure and that particular outcome. In other words, with this no group right here, we have 198 people in it, and it turns out that 49 of them, or this 24.7%, had the outcome that we were looking for. In this yes group, we have 23. Now, if that were the same as the unexposed group, or 24.7, we would expect approximately 25% of 23, which is somewhere around the order of about 6. Well, instead of having 6, we had 14. We had 8 whole extra right here. And so that difference is 36.2 per 100. And so it's this sidebar right here. It's the amount that the risk in the exposed group is higher than the risk in the unexposed group. So that's our attributable risk. Now, attributable risk has lots of different names. You will see it called risk difference. You will, and the book very well pointed out that it could be a risk difference, it could be a rate difference, it could be a prevalence difference, it could be a mortality difference. And so here we have whatever's happening, mortality or risk or prevalence, in the exposed group minus the unexposed group. And so this is how much of the risk can we attribute to the exposure itself. So here we are attributing the risk to that exposure. So attributable risk, I really like that term because attributable helps me remember that I'm attributing it to something. Risk difference is also very good because whenever you're finding a difference in mathematics, you're subtracting. And that's exactly what we're doing here, is we're subtracting the risk of one group from the other group. So we came up in this case with 36.2 as our difference. The next thing that I'd like to show you is something called attributable risk percent. And this looks very, very similar, and we're going to end up with this 36.2 number included, and this is equal to the risk, I'll just use capital R, in the exposed minus the risk in the unexposed divided by the risk in the exposed. And so what this does is, in effect, it shows what percentage of this whole right here, what percent is this top part right from here to here. And so of the whole 23, what part of it is more than we would expect? So let's go ahead and put the numbers in. In this particular situation, we would add 60.9 minus 24.7 divided by 60.9, and this equals 59.3%, or 0.593. So if we took this whole entire, let me go ahead and shade it. If we took this whole thing and we said, what percentage of it is above the line right here that we're saying is kind of like our baseline or our no extra risk, what percent of it is above that? And it ends up being about 60%. So if we take this ends up being the same thing as the 36.2. 36.2 is about 60% of 60.9. So that's our attributable risk percent. Now this also has some other names. This is called etiologic fraction. And that really is an important terminology. Attributable risk percent can sound complicated, but etiologic fraction, I really like that term because it tells us that what this gives us information about is it gives us information about the etiology of disease. And in fact, both of these, risk difference, attributable risk, up here at the top, and etiologic fraction tell us about the etiology. So we'll come back to that when we talk a little bit more about the comparisons and how we interpret these. So those are just a couple of other names for attributable risk and attributable risk percent. Now, moving on, the next thing that we're going to be looking at is population attributable risk and the coordinating percentage. So in order to look at that particular number, I'm going to need to draw a new graph. And so I'm basically taking this same information here, except I'm going to draw this graph in a slightly different way. I'm going to draw it. Let's see, how far down do I need to start? I'll start here. So I'm going to keep the same axis from 0 to 1. And instead, I'm going to make sure that I have a proportionate amount here. And so by proportionate amount, what I mean is if I look at the actual percentage right here of the population that is in this yes group and the proportion that's in the no group, I have 23 out of 221, which that is equal to 10.4% is in the exposed yes group, and what that leaves is 89.6% is in this unexposed group. So I'm going to draw those for this population attributable risk and population attributable risk percent. I'm going to draw that proportionately. So here's 20, 40, 60, 80, 100. I'm going to say that here's about my 10% mark. And remember how we had, let me get a different color, 0.247. And here's approximately 0.609. So I have essentially almost 90% of my population is in this 24.7% category. And then I have another group that is about, here's my 10%, and they are at 60.9. Oops, let me erase that. That's not very straight. I want that to come down a little straighter. Is in this segment. Now, if there was no association between, again, here's my no group, not exposed, and here's my yes exposed group. If there was no association, I'd expect this group, the yes group, to have about the same amount of the outcome of interest. And so with population attributable risk, what I'm looking for is how much does the risk in my population go up because I have a certain number that are in the yes group. Now, the interesting thing too that we can look at here is we have this number that's the total. We have 28.5% had this particular outcome. And I'm going to go ahead and draw that. Let's use a black and say, okay, we have 24.7 in our unexposed group and 60.9% in our exposed group. But what that averages out to, once you take absolutely everyone in our study, is we end up with this 28.5. So let me put a little dashed line across here. This is clearly getting disproportionate the longer we go on. And so here's 28 point, what did I say? 5 or 0.285. And so what I need to know is for the population attributable risk, the question that I have is the risk total minus the risk unexposed. And so let's go back up here and take a look at that. My risk total is 28.5. 28.5 per 100, and my risk unexposed is 24.7. So what I'm essentially doing is I'm finding out the difference here between what I totally have in my population and what I would have if nobody was exposed. And so in this case, here we have 28.5 minus 24.7, which, if you calculate that out, that is 3.8. Now remember, all of these are per 100. And so you may have some other unit of measure if you're doing some other kind of thing, but our population attributable risk in this specific case is 3.8. Now I hope it doesn't escape you that what if the percent that was a yes was actually closer to, let's say, maybe even half of the population. What that means is that this top box right here would actually grow, and that means that our population would go up. In fact, if the number of yeses exposed approaches 100%, then this population number would actually approach the 60.9. And so as the proportion in the population who is exposed changes, population attributable risk actually changes. It goes up or down alongside the percentage that's exposed, and the population goes up or down. I hope this is going to be an easy corollary then. If I take population attributable risk and I want to take population attributable risk percent, this would be equal to the risk in the total minus the risk in the unexposed divided by the risk in the total. And so in this particular case, we have 28.5 minus 24.7 divided by 28.5. In other words, what percent of this 28.5 is due to the exposure? And what we end up with in this particular case is we end up with 13.3%. So, in other words, 13.3% is within the population that we're studying is attributable to the yeses. The rest of it is just kind of like this baseline, would be there no matter what we did, kind of level, that's kind of just always there. And then we have this increase over that that is we can attribute within the population to that particular exposure. So the part of the risk that can be attributable within the population. And so those are the 4 new things that we've learned to calculate. And so I've given you an example of all of those. And so we've looked at the concepts themselves. So let's go back up here to the top. And so what we just did is concepts. Now what I want to do next is I'll scroll over here to the right just a little bit, and I want to compare those different things. And a lot of times the comparison comes down to what I would actually use those for. In other words, if I have a risk difference equal to 36.2, how do I interpret that? So I could say compare and interpret. So the comparison and the interpretation. If I have an attributable risk of 36.2 per 100, or 36.2%, what I'm measuring with that attributable risk is among, and I'll just put exposed, how much of the total risk for outcome is due to the exposure. So let's apply that to this specific case. So among the exposed, remember the exposed in this particular situation were those who were abused. Among those who were exposed to abuse, how much of the total risk for the outcome, in this case was suicide, is due to the abuse? And remember, in in this particular scenario, we're only looking at these two things. It could be that there are other confounding factors and a lot of other things that we need to consider. But if we just do this analysis with those two variables, the attributable risk is asking this question: how much of the total risk for suicide is due to abuse? And what we can say is, kind of going back to this chart, we can say we think that this much of the risk up here, or 36.2 per 100, is due to the abuse. If we think about this in terms of attributable risk percent, there's not much of a change. The attributable risk percent is this exact same phrase, except instead of saying how much of the total risk for suicide is due to abuse, we change that to what percentage. So we'll just replace that blue squiggly line with among the abused, what percentage of the total risk for suicide is due to abuse. And so here we get a percentage, 59.3%. So this is an absolute measure of effect, whereas here we get a relative measure. And so a lot of times we think of things in terms of absolute versus relative. If we were looking at these same exact two things, if we were looking at attributable risk and attributable risk percent in terms of an intervention, like maybe immunizations or health training or that kind of thing, we would call this absolute. Attributable risk, we would call this absolute risk reduction. And we would call the attributable risk percent, we would call this relative risk reduction. And so see how we're using the words here, absolute and relative? In other words, relative is what percentage. Absolute is the per 100. We're using the original scale that we measured the risk in the first place, the risk in the unexposed, the risk total, the risk in the exposed. So that's kind of the difference here between the absolute and the relative. Population attributable risk is doing something very similar. Let's see if I can keep that in the frame still. And this is among this particular population. Remember, our population was chemically dependent adolescents. So among our particular population that we're interested in, let's go back here. Let me get a better color. Among our target population, again, how much of the total risk for outcome is due to exposure. So let's specifically make it for this particular group. Among chemically dependent adolescents, how much of the total risk for suicide is due to abuse or history of abuse? You would have to read the sidebar in the chapter to find out how these two were exactly defined. And so that is our population attributable risk. Again, it is in the same units that we originally were studying, that we're calculating the risk total and the risk in the unexposed. We can change that, though, fairly easily and quickly by, instead of saying how much of the total risk, we can say what percentage. So we take this exact same wording, we say among chemically dependent adolescents, instead of how much of the total risk, we say what percentage of the total risk for suicide is due to abuse. And here we're saying, it's 13.3%. And if you take 13.3% and you multiply it times this number 23, or sorry, you multiply this number 63, you will get this approximately 8%. So this right here is representing this 13.3% of the total suicides. That's how much we can attribute to having that exposure. Remember, all of the yeses is not necessarily due to that exposure. There's a baseline amount that would have been happening anyway, and so that's where we're getting that 13.3%. So 13.3% of the total number that had the suicide, the 63. So we could have prevented approximately 8 suicides if we had known that this exposure would lead to the outcome that we're interested in looking at, and we were able to have some kind of intervention that would prevent those. So that concludes my talk, and I hope that was helpful.